everyone. Today we're going to be talking about a specific kind of relation called a function. So like I said, a function is a special type of relation in which each input value or x value has only one output value, y. So this is just a fancy way to say that x values should not repeat. Okay, I like to think of functions as birthdays. So if I have a birthday, Miss Lynch has a birthday that is May 27th. Tommy may have a birthday that's October 15th. Okay. Each x value, each person can only have one birthday. I can't have a birthday on May 27th and on October 15th. It doesn't work that way. But somebody else, another x value, another person, say Miss Bruno, Miss B, might have a birthday that's the same as mine. I don't think it is, but it might be. Okay. It's okay for two separate x values to have the same y value. Two separate people can have the same birthday. What I cannot have is for one person or one x value to have two separate y values, a different birthday, the 25th of May and the 15th of October. I can't have both of those things. The same thing is true for functions. Your x value should only have one y value. Because they are input values, they're values that are going into a function or into an equation or into a relation, there should only be one number that comes out when you plug in that relation or when you plug in that number. So let's take a look at some of these and determine whether they are functions. So here's an example of a function. I have an input value of 6 that comes out as a 9. I have an input value of -1 that comes out as a 2. Anytime I put these numbers in, they should output whatever their corresponding number is. So 6 gave me 9, -1 gave me 2, 12 gave me 18, -2 gave me 2, 3 gave me 9. None of these x values repeat, so yes, this is a function. Okay, now be careful with these because in this example, my y values repeat. When I plugged in 6, I got 9, and when I plugged in 3, I also got 9. That is not a problem. This still can be a function if the y values repeat. Just like two different people can have the same birthday, two different x values can have the same y value. Where I start to run into trouble is where I have repeating x's. So in this example, I have -1, which gives me 3. I have 4, which when I plug it in should give me 8. When I plug in 2, it should give me 2. When I plug in 8, it should give me -2. And this one tells me that when I plug in 4, I'm going to get 6. Okay. This one tells me that when I plugged in 4, I got an 8. This one tells me that when I plugged in 4, I got a 6. This can happen. It happens all the time with relations. That specific type of relation does not classify as a function. Okay, so if the question is this a function? The answer is no. Okay, so this tells me that 4 has more than one output. Okay, I plugged in 4 and got 8, then I plugged in 4 another time and got 6. This isn't necessarily a problem, but it means that it is not a function. Okay, so let's take a look at a couple of examples. I'm going to do number 1 and number 3, and then I'm going to let you try number 2 and number 4. So remember that I'm looking at my x values. I have 5, 3, 2, 0, and negative 1. None of these repeat, so this is a function. Okay. It is not a problem that my y values repeat. Negative 5 can appear as many times as I want it to in the y column or in the y position of my ordered pair, as long as my x's don't repeat. So I'm going to try this with number 2. I've got negative 4, negative 3, negative 2, 1, and negative 3. That's a problem. Okay, I have 3, which gave me a negative 1. Excuse me, negative 3 gave me a negative 1 here in my first relation, or in my first ordered pair, but negative 3 gave me 2 over here in my second ordered pair. So this is not a function. Okay, so negative 3 has more than one y value or more than one output. I want you to see if you can try to guess whether 2 and 4 are relations. Go ahead and pause the video and try that for just a minute, and then you can come back and check your answer against my answer. All right, so for number 2, you should have gotten no, it is not a function, because 2 had an output of negative 4, and then it had an output of positive 4. Those are 2 separate outputs, so this is not a function. Number 4, I don't have any x values that repeat, so this one is a function. I want to clarify something real quick, in that if I have a relation in which there are more than one x value, so if I have like 3, 1, 6, 5, and then 3, 1, this still is a function because 3 still only has an output of 1. Okay, this can be a little tricky because it doesn't have different output values. 3 is giving you 1 every time you see it. Okay, so you can check that the x values don't repeat, but you also have to make sure that it has different y values. If it has different y values, it is not a function. If they happen to have the same y value, that's just the same point. So that is still a function. Okay. Do the same thing with my tables. I'm going to try, let's say 5, 6, and 7, and then you can try 8, 9, and 10. So let's look at number 6. I want to check my x values. So I've got negative 5, negative 3, 0, 1, and 2. My x values are looking pretty good. None of them repeat. So this is a function. Okay. Number 6, I got negative 4, negative 2, 1, 2, and 5. Again, none of these repeat, so this is a function. 7, I've got 3, negative 1, 0, 2, and 3. The problem is I end up with a 3 that has an output of 5, and I have a 3 that has an output of 3. This is not a function because 3 has more than one output. Go ahead and try 8, 9, and 10, and come back and check your answers against mine. Okay, for number 8, you should have gotten that it is not a function because the 4s repeat. In one instance, I get negative 3 as my output. In the other, I get 2, so that makes this not a function. Number 9 is a function, even though all of my y's repeat. Maybe all of these people have the same birthday. It's a fine thing. It's still a function because my x values do not repeat. My y values can repeat. My x values should not. Number 10, I don't have any repetition here, so that one should be a pretty straightforward yes, it is a function. Okay. Last one we want to look at is maps, and you can handle these in a couple different ways. You can list these out as ordered pairs if you want to. Sometimes that's a little easier to see. So I have an ordered pair of negative 4, 4, because I have a 4 here with the arrow going to my y value of 4. I have a negative 1, negative 1. I have a negative 1, 7. I have a negative 2, 3. and a 1, 7. Okay. And then I can go in and check my x values. So I've got -4, -1, -1, -2, and 1. So my -1s repeat here. One gives me an output of -7, or excuse me, -1. The other gives me an output of 7. So this is not a function. Okay. Another easy way to look at this with mapping is to follow the arrows. If you have an x value that has more than one arrow coming off of it, that's bad. That makes it not a function. Let's look at number 12. Again, I can list these as ordered pairs. That sometimes makes it easier to look at. So I've got -3, 0, -1, 4, 2, 7, and 4, 4. When I look at my x values, I see -3, -1, 2, and 4. No repeats there, so this is a function. Okay. Again, if I follow my arrows, I don't have any x values that have more than one arrow coming out of it. The only thing I have is this double arrow to the 4, but remember that y values can repeat, so this is a function. Why don't you go ahead and try number 13 and check back here to check your answer. So for number 13, you should have gotten that this is a function because none of my x values repeat. It's okay that 2 arrows are pointing to my 2 because it's a y value and y's can repeat. The last thing we're going to talk about is the vertical line test. The vertical line test is an easy way for us to check whether graphs are are functions or are not functions. So the vertical line test is used on graphs to help us determine whether it is or is not a function. So the vertical line test states, if a vertical line, remember vertical lines go up and down, if a vertical line crosses the graph at more than one place, that relation is not a function. So if I have a function that looks like, I don't know, like this, it can be a little hard to determine whether that is a function or not. So what I can do is I can draw a bunch of vertical lines and see where they cross my function. So this first line crosses about right there and nowhere else. This second line crosses right here and nowhere else. And as I continue along, I should find that it's only crossing in one place at a time. It's never touching the graph in more than one place. So I'm going to check it at all the possible points. And I find that this is a function because it only crosses ever at one place. Now, if I have something like this, which is a graph that you'll see in your higher level math classes, this one would not be a function because even though if I draw a vertical line right here, didn't exactly go where I wanted it to go, right here, and technically that does only cross at one place. If I draw it in any other place, like over here, it's now crossing in 2 separate places, and that's bad. That makes this not a function. Okay? So I can do this with discrete graphs. Remember that discrete graphs are ones that have individual points on them. They're like the ones we did when we represented relations. So I can check these with the vertical line test. So I'm going to check here. It only crosses in one place. That's good. I can check here. It only crosses in one place. That's good. Check here. It only crosses in one place. That's good. When I check here, this crosses here and here. So this is not a function because it crosses in more than one place. Okay? If I were to remove this point or remove that point, then it would be a function. But as it stands right now, it is not because it fails the vertical line test right here. Okay? Like I showed in the example, this is true also for continuous graphs or graphs of lines or curves. And I can check this in various places. So it crosses right there and nowhere else. Same thing here and nowhere else. You can put a vertical line anywhere on this graph and you will never cross at more than one place. Okay? Why don't you go ahead and see if you can guess whether number 2 and number 4 will pass the vertical line test. So this one is not a function. Check number 2 and check number 4 with the vertical line test and see if they are or are not functions. Check your answers back here with me. All right, so number 2 is a function. As I check the vertical lines of each of these points, I'm never crossing more than one point at once. So this is a function because it only ever crosses one time. I need to fix my answer here for number 3. I said that this was not a function right after I told you that it is a function. So let me fix that. This is a function because it only ever crosses in one place at a time. Number 4, on the other hand, is not a function because here or here or here, anywhere else besides this point right here, it crosses more than once. Because it crosses more than once, it is not a function. So to finish up these notes, I want you to practice using the vertical line test and tell me whether 5, 6, 7, and 8 are or are not functions. Okay, write your answers down on your paper and then come back and check them against mine. All right, so number 5 is not a function because it can cross more than once. Remember that it only has to do that in one place in order for it to not be a function. If it happens anywhere on the graph, it is automatically not a function. So even if I have a graph that's like this, something like, I don't know, this and then something like that, where it kind of doubles back on itself, even though it's fine all the way through here, the minute I get to this part where there's more than one cross, this is not a function. If it double crosses anywhere, it is not a function. So for number 6, it is a function. There's nowhere that it would cross more than once. For number 7, this one was tricky because the line is a vertical line. Well, that means that if I put a vertical line on top of the line, it's going to cross at all of those places at once. Well, that's more than once at a time, so this is not a function. And then number 8, again, there is nowhere along those lines that a vertical line would cross twice, so this is a function. Okay. If you have any questions, make sure you write them down, and we'll go over them in class.